Welcome to all. Today we will see the combination circuits. That is our second unit. So you know unit 1 is completed. Now go for second unit. Unit is 2 is combination circuits. Uh, Before that we have to know the two types of digital circuits. Mainly digital circuit can be divided into two circuits. One is combination circuit, another one is sequential circuit. Uh, Here the black diagram of combination circuit and sequential circuit. In this combination circuit, it consists m number of inputs and m number of outputs. Okay, the output depend upon only the inputs. The combination circuit means it is a combinations of logic gates. Okay, uh, logic gate circuit. Okay, the output of the combination circuit depend upon only the inputs. But in sequential circuit, the output is fed back and given to memory, and the output of the memory is again fed back to the feedback and given as a input to the sequential circuit. Okay, so here we are using another extra element, memory element, for storing the output and given to the input. Okay, so here the output depends, these are all the these are all input, these are all output. The output depend upon present input and previous output. Okay, because the output is feedback and given as the input. Okay, so the output depend upon present input and previous output. Okay, this circuit is called sequential circuit. This is combination circuit. We will see the combination circuits in unit 2. For a combination example for combination circuit is adder, subtractor, multiplexer, simply we can say mux, demux, encoder, decoder, parity checker, code converter. We will see in this unit all the combination circuits. Okay, these are all the some few examples. Okay, now we go for combination circuit with an example, that is adder. Adder circuit. So for decimal addition, for 2 bit, that is for decimal addition, if you have 2 bits, that is 00, what is the output? 0. If one input is 0, another input is 1, then what is the output? 1. If one input is like this 1 0, what is the output? 1. This is decimal addition. Okay, next if you put binary addition, very sorry, this is binary addition. Next for binary addition, if you add this to 1, we get, that is 0. This bit is sum bit, that is MSB, most significant bit is sum bit, least significant bit least significant bit is sum, most significant bit, that is this bit is carry. Okay, so this is the addition of binary addition, the binary addition of two binary bits. Okay, next we will see the types of adder. Adder we can divide into two, that is one is half adder, binary addition, and another one is full adder. If the input variable is 2, then the half adder is half adder. For half adder, input variable is 2. So sum, carry. Okay, this is half adder. If in the input variable is 2, Then the circuit is called half adder circuit. Outputs are sum and carry. Okay, if the input variable is 3, that is A, B, C. If the input variable is 3, then you can write here also. C, this is full adder. Okay, now we see the half adder separately. Okay, half adder. Okay, half adder. Truth table for half adder is, so A, B are input. Okay, output sum and carry are output. Carry are output. So two variables are input variables for half adder. This is the black diagram for half adder. So A, B, two output sum and carry. Okay. So the two input variables means what are the two input combinations of binary? That is 0 0 one combination, 0 1 another combination, 1 0 another combination, 1 1 another combination. So next, if we add 0 0, what is the sum? If we add 0 0, what is the sum? 0, sum is also 0 and carry also. Carry here no bits means that is 0. Both are 0. That is sum also 0, carry also 0. If we add 0 1, if we add 0 1, sum is 1, carry is 0. If we add 1 0, 1 0. If we add 1 0, similarly the same answer, sum is 1, carry is 0. If we add 1 1 like this, sum is 0, this is sum, carry is 1. Okay, so sum is 0, carry is 1. Okay, this is the truth table for half adder. Next, we have to draw the circuit diagram for the half adder with this truth table. So, uh, for before going to draw the circuit, we have to simplify the table with K-map. Okay, so K-map simplification. K-map for sum. Okay, so here input variables are two. So two variable K-map we have to draw. So this is A, this is B. Okay, so put A bar here, A here, B bar here, B here. Okay, next that is 0 means A bar and here 0 means B bar. So A bar and B bar we put sum 0. Okay, similarly this is A bar, this is B. So A bar, B. Intersection of this row and column we put that sum is 1. Similarly, this is A, that is 1 means no bar. So here B 0, so put 1. So A means this row and B bar this row, this column. Intersection of this row and column we put sum output is 1. And similarly A, B, no bar, that is both are A, B. That is the intersection of this row and this column we put, what is the sum? 0. Next, go for grouping. We cannot go for one group and also we cannot group two ones. Okay, if we are having here one means we can group like this and group like this, but here we cannot, it is not possible to have two one grouping, so we have to group like this single one. Okay, for this one, for sum we have to write sum. For this one we have to write the equation from this K-map. That is, one means corresponding row and corresponding column you have to see. That is, corresponding row we are having one variable A and column we are having B bar. Okay. Similarly, this row we put plus. For this one, corresponding row we are having A variable and corresponding column we are having B variable. So actually this equation is XOR gate output. Okay, so just simply we can write like this is XOR addition output. Okay, already I taught this one in XOR logic gate. Okay, that is A B bar plus A bar B. This is XOR addition output. Okay, we can write like A plus that is XOR addition symbol B. Okay, this is sum. Okay, similarly we have to draw for carry. So I am going to write here K map for carry. Okay, similarly so two variables A B, so A bar A here, B bar B here. So for A bar B bar, so we put 0, and A bar B we put 0 here. For A B bar A B bar, in this row carry is 0. Okay, finally both are 1, that is A B, both are 1, so A B, here is 1, so we put 1. So only one is present, so we have to group like this. So for this one we have to write equation, that is carry equation for this. So in this row we are having A and in this column we are having B. So this is the equation for carry and this is the equation for sum. Okay, we have to draw the circuit diagram for this sum and carry. Okay. Next, logic diagram. For sum, XOR gate is used. Okay, we put XOR symbol. This is sum. So two inputs, that is A, B. So A, B. So what is the sum? That is XOR addition. A plus, that is A XOR B. This is called XOR symbol. Okay. Similarly, next carry. For carry, AND gate is used. B. So this is A and B. A B. This is A. Sorry. This is B and this is A. Output is A B. This is carry. A B. This is the logic diagram or circuit diagram for half adder circuit. Okay. Next we go for full adder. For full adder we have to use 3 inputs. Then only it is called full adder. Okay. First we have to draw the truth table for full adder. Then go for K-map simplification and then go for logic diagram. This is the step for designing of full adder. Okay. So truth table for full adder. So before that, logic diagram is, that is full adder. You have to give three inputs. So A, B, C. Two outputs. Sum, carry are two outputs. Okay. Truth table for full adder. So input variables. Inputs are A, B, C. Output is sum, carry. Carry are outputs. What are the three input combinations? 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These are all the three input combinations. Okay. We have to calculate the three input combinations. We have to calculate the sum and carry for these three input combinations. For sum, we have to add the three input variables A, B, C. So how can we add? First add these two variables. From the answer, we have to add this variable. Okay, so addition of these three variables is 0. That is sum 0 and carry also, sorry, sum 0 and carry also 0. So we put it here, sum and carry also 0. Next go for this one, 1. Next go for the input 0, 0, 1. That is 0, 0, 1. Okay. What is the answer? If you are adding 0, 0, our output is 0. From this output 0 plus 1, that is sum is 1 and carry is 0. Okay. So sum is 1, carry is 0. Next input is 0, 1, 0. Okay, if you add 0, 1, sum is 1 and add this 1 and 0, we get 1 is sum is 1, carry is 0. Okay, similarly next 0, 1, input is 0, 1. If you add 0, 1, sum is 1, carry is 0. And then we have to add this one. Okay, this is A, B, C. Okay, so if I add this one, this is this one, that is sum is 0, carry is added with 0, that is carry is 1. So here sum is carry. So carry is 1, sum is 0. Similarly, if I add 1, 0, sum is sum is 1, carry is 0, and if next for this input we put 0 here. So sum is 1, carry is 0. So sum 1, carry 0. So sum 1, carry 0. Next this input, that is if you add 1, 0, this for this, first you have to add this one, that is 1, 0. So sum is 1, carry is 0. Next you have to add this one, sum is 0, remaining carry is added with 0, then the answer is 1. This is sum, this is carry. Okay, so put sum 0 and carry 1. Okay, similarly if I add 1, 1, sum is 0, carry is 1. Okay, next we have to add 0 for this 1, 1. The result of the 1, 1 is, the result of the 1, 1 is 1, 0. Next add this 0 with this result. So here sum is 0 and 1 is carry is 1. So sum 0, carry is 1. Okay, next all are 1. So 1 1. First you have to add this 2 1. So addition of 2 1 is 1 0, and add with this one. So 1. If you are adding 0 1, so 1 and 1. So sum is 1, carry also 1. So both are 1. Okay, this is the truth table for full ladder circuit. Okay, next to go for simplification. Okay, for sum, K-map for sum. So here 3 variable inputs, so we have to use 3 variable K-map. So we put it here A1 variable, BC remaining order. So A bar, BC, 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 BC. Put bar here, and bar here. We can use min term place also. This is 0, and this is 1, this is 2, this is 3, this is 4, 5, this is 6, this is 7. Okay, so what is minimum questions? That is in decimal. What is this? What is the equivalent for this 0 decimal? Binary this is the binary. Equivalent decimal is 0. For this binary, equivalent decimal is 1. For this binary, equivalent decimal is 2. This binary equivalent decimal is 3. This binary is 4. And this 5. This 6. And 7. Okay, from this, we can take this decimal as a min-term places in K-map. Okay, so for some 0th place, for 0, the min-term 0, we put sum is 0, and 1 we put 1. For min-term 2, we put 1. Here is the second min-term. 3, third place, min-term third place, sum is 0. And fourth place we put 1, and fifth place 0, and sixth place also 0, and seventh place we put 1. Okay, now we have to grouping number of ones. Okay, 8-1 group is also not possible, 4-1 group also not possible. Okay, so 2-1 group also not possible. So we can group like this only. There is 1, 1, 1. Okay, so for this we have to write the equation. That is sum equation. We have to write the sum equation. That is for this one. What is the um, expression? We have to compare. We have to see the row and column variable. For this row we put A. For this column B, C bar. Okay. Similarly this one A, B, C. A, B, C. For this one A bar and corresponding column B, C, plus this one A bar and corresponding column B, C bar. This is the expression for sum. Okay, and logic diagram for this sum is we put 4 AND gate. And addition of all the product term. So we put one OR gate for addition operation. This is OR gate. Okay, for first AND gate, what are the inputs? 3 inputs. That is A, B bar, C bar. A, B, C. A bar, B bar, C. A bar, B, C bar. So this is the logic diagram for sum. Sum is the output. Okay. Next, um, uh, next we have to simplify the output for carry by using K-map. Okay. So K-map carry output. Okay. So for carry, for minterm 0 we put 0. For minterm 1 we put 0. For minterm 2 we put 0. This is third minterm. Minterm 0 we put 1. For minterm 4 we put 0. For minterm 5 we put 1 and 6 1 and finally 7 1. Okay, 4 1 group is not possible, then go to 2 1 grouping. First we can take like this. So this is carry, we have to write the equation carry. What is the equation? That is A, and corresponding column we have to compare this variable. Common is C variable, we put C here. Next we can group like this. So for this row, A variable, comparing this to column, B variable. Okay, next you can group like this. Sorry, comparing these two column, you can cancel each other, and we can take this two variables B, C. Okay, this is the expression for carry. So we have to use 3 AND gates. All gates are added with an OR gate. So this is carry. So input is A, C, A, B, B, C. This is the carry output. Okay. Okay. Next we will see the subtractor circuit next class. Thank you.